Good morning, everybody, and welcome to the EclipseCon France. We're talking about EMF Xtend to have a builder of EMF models, BOEM. Today we're going to present it's Daussy from Obeo and me, Jacob Geisel. We're going to present BOEM today. I'm going to begin a bit about the context of the project. Arthur and me, we're working for Obeo, and it's a collaboration with EBP, which is the computer branch from the Banque Populaire, a bank group in France. And it's a migration project from rational rows to modern technologies like EMF and series. It's rational rows, it's end of lifetime since I think 2006, and they defined a language for their model-driven engineering tool suite to build their business applications at the Banque Populaire, and that was based on a UML stereotype language. We had a bit of problems. There were not as much specifications of that language as we would like to have. It's in use for 15 years now, and there's a huge legacy part of the models they have built during those 15 years. There's about 1.5 million semantic instances. Those instances are split into a bit more than 1,700 resources. There are cyclic references and stuff like that. In rational rows, through add-ons, there were all the business rules for validation and for the reference scopes, which were defined in Visual Basic, which we translated into pure Java with EMF.
So, as Jacob described, we are facing a big and complex modeling language. For the record, at the beginning of the project, we have like 300 concepts. It's about the same number of concepts as UML. And we were facing a lot of business rules, which were context dependent. And we quickly realized that we really needed a lot of tests. So the main goal of BOEM was to write tests efficiently. The second aim was, at the beginning of the project, we realized that modeling language was old and there were a lot of deprecated stuff, unused stuff, and some stuff that we could do better with EMF. So we wanted to be able to refactor the language during the migration project. To do so, we needed a way, so when changing the language, we wanted to have instant feedbacks on what has changed in our tests. That's why we needed compilation. So when I change the metamodel, I generate and I see all the tests broken before running them. Then, so we needed flexibility. The other part is the current implementation lasted like between 10 and 15 years, and we are pretty confident that this one will last as long. So to make it maintainable, we need readable tests. So this is the third focus of BOEM, is making tests readable. And last but not least, for all of you who worked on migration project, you know that it could be tedious. It's long, it can be hard and frustrating task. So we needed to keep interest in the project. We didn't want to lose anyone during the migration project. To do so, we choose to add a new and fun technology to the project for making tests, so everybody could keep learning some stuff. Because this is the main interest for an engineer, as for me, is to keep learning some stuff. So we wanted to introduce a new technology. We didn't want new fancy technologies that would die in 2 years, and we didn't want a technology that would bring a whole entire new stack. We just wanted something like would perfectly match in our context. And that's where Xtend comes into place.
Now a bit to Xtend, which Arthur introduced. Xtend is a language which transpiled to pure Java 8. And even the transpiled code is still more or less human readable. And other parts of Xtend is there's a lot of extension possibilities to define syntactic sugar on the code you're going to write. So that's why we decided to use the Xtend language. We built an editor for EMF models, which allows us to represent those EMF models in a JSON-like syntax, which allows us to write them quite fast and quite easily, and they resemble, they look a lot like the tree-based editor everybody knows from EMF. The tests are compiling, so if you change the name of an attribute in your meta model, you really have problems to reload serialized models. In our case, you have a compilation problem, which is easy to handle through just changing the code, or even via auto-completion, which is given by the Xtend editor. The code, since it's really readable, it is easy maintainable. You have a flat learning curve. Everybody in the modeling or in our project knew how the tree-based editor looked like. It's the way they did it in rational rows, and so we knew how to use it. Everybody knows JSON, so it's really quite easy to write, easy to read. It's a lightweight library. We have less than 500 lines of code, thanks to Xtend and the extension mechanisms. So it's not that big of a project, but the use of writing easily compiling models, not just through the Java API of EMF, but really readable models, was quite impacting. We've discussed with people from the modeling community, with people from Obeo, and they were all in line with us that there's real need for building models as test inputs, which are compiling to view the changes from the meta model. We are using BOEM now for 2 years in our project. We wrote a couple of thousands of tests for the scopes and the business rules, which allows us to really build models with a specific context to test those business rules and the scopes. And last point, we got the idea to write those all that in Xtend and to build a modeler kind of in Xtend was inspired by a talk by Max Burek during the EclipseCon 2 years ago.
So now the setup part. We wanted to present setup part on how to use BOEM and how to set up BOEM, because it was an important focus we had. We wanted something lightweight and really fast to install in your project. So to do so, go to the GitHub page of the project. You will find there all the source of the library and a README documentation. So you have a description. The second chapter is the installation chapter. You will find an update site where you can get the library built for you. The description, some documentation on how to write BOEM, how to use BOEM, and the last part is a link to this presentation if you want to, if you need it later. So, to first use BOEM, you would need to have a dependency to the project, which is BOEM lib. This is the only BOEM dependency you will need.
Oui.
So the only dependencies. Okay, let's go on. The only dependency you would need is BOEM dependencies. If you use an ID, Eclipse ID with the correct tooling, you will have a quick fix asking you to add those dependencies. It's mainly Guava, Xtend, and Xtext dependencies. And it's done for you if you use the correct tooling. If you don't, you just have to add them. Okay, the second step is to create a BOEM factory. So a BOEM factory is a factory to create EMF object and BOEM objects. It's an object we take only one argument, which is the instance of your package. In this case, your instance. We like to use it as an extension attribute of an Xtend class. It makes all its methods available on your code without using the factory keyword. So it makes your code really simpler and easier to read. Next is to import the BOEM API. You do this with one statement, which is an import static extension statement, where you import the BOEM library, in which you have static methods and operator overload that will be available in your code. And you're ready to go. So the next part is some steps on how do you do it in BOEM.
Okay, now we're going to show some kind of real-world tests. So, in fact, the tests we were using to build a BOEM. First thing we're going to show you is how to create an object or an instance of a metamodel. We used UML because UML was, for our case, size quite similar to the language we were using, and it's a language almost everybody knows more or less, and it's quite complex language. In fact, what you're seeing here are all the tests we wrote, those just basic JUnit tests. You have the factory for the UML package, and what you just need to do is to define a variable or a final variable in EMF val, the name of the variable, and you have a model, which is the model interface from UML. You build the instance. You can handle all the attributes from the element either using it, which is kind of self in Xtend, but you don't even need to set it. You can set the attributes like the string for the name or the enumeration of the visibility. You can even create nested elements, like for the packaged elements in the model. You build the interfaces. In an interface, you can build the own operations. All that resembles quite much to JSON style code.
C'était pas celui-là.
Non.
Ok. Ouais, mais il veut pas. Voilà. Okay. So Jacob showed you how to write and create new instance of EMF objects. Now I'm going to show you how to create trees and resource and BOEM elements. So here again we have a test. So the test is quite similar to the other one. We just create a model, we set its name, its visibility, and some other stuff. The only difference with the previous example is that we use the build tree methods. Build tree methods, instead of returning any object, it returns a model accessor. The model accessor is just a wrapper for your model. It gives you access to the root of your model or other part of your model using an ID mechanism that will be described later, and some utility methods. You have two signatures for the build tree methods. One which takes no argument, saying, okay, I just want to build a tree, or the second one which is presented here, which takes a resource set and URI. So BOEM will create a model, add it to a new resource, and add it to your resource sets.
Okay. Now, once we have built our object or tree, we want to also access those objects we created via different methods.
Oh, sorry.
As Arthur just explained, you have the model accessor, which is kind of accessor, and you have different ways to access the objects. You either define an ID, which you inject into, this example, the interface to really give an ID to the interface, and via the model accessor you can access an interface with that ID, or you have a shorthand way to do it without a cast, just using the ID and the model accessor.
Next. So one of the main goals of BOEM was to be fast writing text, so we need a way to add multiple elements, new elements in one time. So this is test. So again, we create a model named visibility, and now we want to add several interfaces in my package element containment reference. To do this, we use the plus equal keyword or operator Xtend, which means adds to a collection, and we define a collection using the set syntax of Xtext, which is this one. Now we're gonna add 3 interfaces. 2 of them we give it some IDs, so human interface and human interface 2, and the second one we don't add one. So you can use both syntax, adding IDs or not.
Now, once we have a couple of objects, we need to reuse them, and so now we need to reuse those references or the IDs of the objects we just built. There are 2 ways to do it. Either you create simply an interface and you reuse it, just the variable of the interface. And another way to do it is to use the IDs you defined earlier or afterwards. Here we define UML interface. Here we define UML interface 2, and we add a generalization to this second interface using the reference on the interface, which is called UML reference, or using a shorthand way, which is even easier to read and easier to write. We use the interface and we kind of inject the instance which is created with the ID UML interface 2.
So this was also described by the previous test, so I'm going to skip this one. Oh. So when we were writing BOEM test, we quickly understood that giving these IDs, specific IDs, was kind of hard, and mostly in some language there are predefined IDs which make sense for the users. For example, in the EMF Metamodel, we could say, okay, I can use the name as an ID for each object. If I only use unique IDs, I can use it. So you can register in your BOEM factory an ID provider. This ID provider will define for each element which has a name. It says, okay, the default ID for this element is its name. And if you don't have any rules, return new, and say, okay, it doesn't have any IDs. It can be overridden by the previous mechanism to specify implicit IDs, but you still can use this one. So just have a look at this. So, for example, on these tests, we just define there the ID provider we described, and now we're creating a model, and we don't need to define specific IDs, since they all have names, IT1, human model, IT2, and now to create the references, I only use the ID that we are computing for the name of each element. So here, I set specific reference to the interface with the ID IT2. Last part is how to update the model. So first you create your model, you make some verification, and you want to later modify it. So again, on our tests, we create the models, and we do some checks. Now I just want to modify a part of my model. To do it, I use the update methods, which have two signatures. One taking no argument, meaning I want to update the roots of my model, or at least from the roots, or I can only update some part of my model using the second signature, saying, okay, I want to update my model from the point which is generalization and with the ID UMLGen. In this syntax, I only modify a part of my model, and of course, I can reuse the ID defined before. So on this one, I add this generalization, I add a new interface in my model, and now I change the general features to the new created interface. Okay, now just a real-time demonstration, because we want to demonstrate that it's really fast and easy to write a BOEM model. So in this demonstration, we are going to write the model you have seen on the previous test, which is a model, 3 interface, 1 generation link, and an operation with a parameter. This part is optional depending on the time we have left. Okay, so let's go to the presentation. So we just created a default Xtend class with a test annotation here because we want to run a test, and we extend an abstract UML test which only configure a resource set to underwell UML resource, and we define a new array here, so the model could be saved just close to our test, so you will see in real time the model that we built. So the first step is how to add some elements in my tree. So to do this, Jacob only use a completion. So I have completion on the name of my features, and I have completion on the name of my elements, because we have interface for the elements, and this is a simple getter in Xtend. So to add more than one element, you use the collection syntax, which can be a set or list. Let's start with this, and you build the 3 interface. So in this model, I'm going to build my model with 3 new interfaces, which has no name for the moment. So we run the tests, and now we're going to serialize it in a model, just to see how it's represented in a basic UML tree editor. To do this, we use the build tree keyword that we have previously demonstrated, and we're going to give him a resource set and a new array. Okay, so the resource set comes from the abstract class that we showed you earlier, and the URI too.
That's too much code. I don't know.
No, the tree is here. Okay. So we're going to get the resource and save it.
Oh.
Okay, so let's run our test again. And now if you refresh the view here, you will have the new test models as defined, normally defined. Okay, next step, we are going to create a generalization link with inheritance between 2 interfaces. So we'll give a name to each interface and register an ID provider, so the name will be used as ID to create references. Again, on all edition you have completion thanks to Xtend. This is not a specific editor for BOEM, it's just the generic Xtend editor, so you don't need special tooling to use this. Xtend, the one for Xtend. Okay, so for each element, uses them as ID, and now we're going to create the last element, which is a generation link between two interfaces. We're going to use a short syntax, so the model looks smaller. We could use also the second syntax that Jacob presented you with a big dash. In general, in BOEM, we have always two syntax. One is more verbose, it's more easy to understand for a newcomer, and one which is more concise, which makes the model smaller and so easier to read. Again, we run the tests, refresh the model, and here we now have our generation. You want to do the last part, or?
The method? No.
Yeah. Okay, so let's go back to the presentation. Now we will compare the three representations of a model. Which is, the first one is the UML one.
No. Hold it.
The first one on your left is the UML one. You have this one on the basic tree UML editor. It's quite concise. You have most of the information you need, but you don't have all properties, but still it's understandable. The fallbacks are, the first, you need an external editor to edit it. First, it could be tedious to edit because you always right-click, new element, then you change to the property view, you set an attribute or a reference, and it will be long. And if you change the language of your modeling language, you are mostly have to change the editor you are using. So it's not really flexible. The second representation is the BOEM one. So it's a bit longer, but still you still have the tree structure you have on the left. You have all the information you need because you have its name reflected here. You have all references represented. And as we demonstrated, it's quite easy to write using completion and Xtend editor. We didn't talk about it, but the default Xtend formatters format the code like this, so you don't even have to customize your formatter. So the benefits are, it's quite short, it's quite fast to write, fast to read, and if you change your model, you have a compilation error that will appear at the beginning of the line. So you just see immediately what line you have to change, and it's quite fast. The last representation is the Java one. So it's longer, obviously, because you just use the standard Java API. You have the compilation, because it's just Java. However, you don't have the tree structure, and I think we can agree that it's less readable and maintainable.
So that's the status quo. That's what we've done to now. Now we still have some future plans for BOEM. One is the serialization of existing models into BOEM code. We know there's a lot of models which are used for testing out there. So we want to offer a kind of way to serialize or to generate the BOEM code from existing models. And that's one point we're kind of working on. The next point is we would like to have some interaction with the people who are building Xtend, and to have two things we realized when working on BOEM. That was the enumeration completion could be better, so that's one point we would like to work on. And another one which would be very beneficial for BOEM, that's the code folding for lambda expressions that would allow us to just fold parts of the tree we defined. Another point is the integration of series and BOEM. Two points. One is to handle the series sessions inside from BOEM, and also to be able to initialize representations, series representations, to later on have tests on those. So if you see, or if you're using it and you see any uncovered requirements on that, just come talk to us, or fork it on GitHub and make a pull request, or raise some issues. It's an open source project. So thanks a lot for your attention. And if you have any questions, I think we have 3 or 4 minutes left. And one last thing, thanks a lot to Nicolas, who's there, and Laurent. No, those are 2 people from we worked at Banque Populaire on BOEM and on other projects. Okay, thank you. Don't forget where the EclipseCon vote for the talks you like.